Alright, what is up everybody, and I'm back with another video, and in today's video we're going to cover a PLA question, and we're going to draw a PLA graph with these two Karnaugh maps. And the question is, input the following two functions on the same PLA that has 4 AND gates and 2 OR gates. We have function f and functions g, and we're going to implement these two functions on a PLA graph. Alright, so that's what we're going to do today. So to start off, if you don't already know what Karnaugh maps are, it's just graphs that are made like these, rectangles, you could say. And what they do is it kind of helps us to simplify electrical circuit equations. Okay, so whenever you see this A line here and there's a line here, that means everything under A. So for example, these 4 numbers are when A is equal to 1, right? So that's what happened when A is covering that position. Now this B is here. These 4 numbers are when B is equal to 1, right? And then C is here. The bar's covering this row. So this row is when C is equal to 1. Now if it's not covering a certain row or column, that means that that is equal to 0, right? So how do we better draw this? We can better draw this again if we were to make our own graph for like a better understanding. Let's put a 1 1 0 0 1 1 0 1. So we can put something here, and this will be AB because we have 2 letters on the top, and then C will be at the bottom. So we know that C is 1 on the bottom row, so let's put when C is equal to 1. And then here, because there's no line from C covering this row, we know here's when C is equal to 0. Now for A and B, in the first column, there's no lines over this column from A or B, so we know that A is 0 and B is 0. In this one, A doesn't cover this column, but B covers this column, so we know that A is 0 and B is 1. In this column, we have A and B both over the same column, covering with their lines, so we get 1 for A and 1 for B. And in this column, B doesn't cover it, so B is 0, but A covers this column with the line on top, so A is equal to 1, so then we get 1 0, right? So these are what we get with the 3 values connected. So when A is 0, B is 0, and C is 1, then we get a 1 value. When A is 0, B is 1, and C is 0, then we also get a 1 value. So that is another way of how to draw it. Now, if we look at the f function right here, we can circle Karnaugh maps in any number that is an exponent of 2, right? So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. What I mean by that is when we circle these 1s, we can only circle 1, 2, 4, 8, and etc. It has to be an exponent number variable of 2. So we can't circle 3, we can't circle 5, we can't circle 6. We can only circle these amount of 1s, okay? So if you guys want me to go over Karnaugh maps more in detail after, please drop down a comment and I'll make sure to make a further, more detailed video on that with a problem that we could do together. But assuming you guys already know how to do a bit of Karnaugh maps, let's get into it. So now we have to circle them, right? So when we circle them, what can we do? So let's circle the first one for this f function. So how about we circle these 2 1s, right? So we can circle these 2 1s over here, right? So those are 2 1s that we can circle because we can only circle 2 1. So let's circle those 2. Then let's also circle the 2 corner ones, because we can circle the corners on Karnaugh maps if you guys remember. Actually, let me use a different color. Let's use green. So we can circle the 2 corner ones because these 2 ones connect to one another. And then we only have 1 left, so this is 2 to the power of 0. So we can circle 1 by itself. So let's circle this one. So now we have 3 over here. We have two ones circled over here. We have one circle on the corner and then one circled by itself over here. Now I wonder if you're wondering, oh, why couldn't we just circle these 2 ones instead, or these 2 ones together instead, and then this would be by itself? There's many different variations of this, but no matter how you do it, you will always get the same final answer. There's many different ways to get to the same final answer. This is just one variation that I'm choosing to do. So we circle the 2 ones on top corner, the 2 ones in the bottom corners, and then one by itself right over here. Now, what we have to do is now we have to formulate an equation for each one that we circled. So if we look at the 2 ones in the top corner, so this would also be known as these 2 ones right here, right? What are the values that are the same and don't differ? That's how we're going to do it. So when both of these numbers are 1, and we look at these 3 numbers, A, B, and C, we know A is 0 and it's 1, and B is 0 and it's 1, and this one is A is 0 and B is 1. So we know that B won't be part of the equation for these 2 top number ones in the top left corner because B changes. So in this one it's 0, right? In this one it's 0, but in this one it's 1. So that means we can't use B as it's not the same to produce the same 1 value. But A is still 0, so we can start off our equation by writing A bar. Because we know A bar is going to be in that equation because A doesn't change. It always stays 0 in the duration of it. Now, when we have both ones here, we also know that C doesn't change. C also remains as 0 throughout the whole process of those 2 ones in the top left corner. So we can also write down C bar. Right? So you have A bar, C bar for the beginning part. Now, we're going to put a or sign here, and now we're going to do the second circle. Now, the second circle we're going to do is the corner one. So we have 1 here and a 1 here. Now we have to find what number stays the same, or what letter I should say stays the same, and what letter differs from those 2 corner ones. So if you look at it, we can see that when there's 1 here, A is 0, but when it's 1 here, A is 1. So now we know that we can't use A in the equation. And if we look at this one here, B is 0 in this one. And if you look at the one here, B is also 0. So we know that B is 0 when both of these numbers are 1 in the corner. So then to let B equal 0, we put B bar. Because we always assume the number is 1 and then the bar just produces the opposite. So we put B bar. Now, when C is 1, this is also 1, and when C is 1, this is also 1. So we know that C also stays the same for both of these values. So then C is 1, so we just put B bar C. Now we have to put another OR 1 for the third circle, which is this one right here, the one by itself. So whenever a circle is by itself, because it doesn't have to be differed by in any way because it's only 1, we just put whatever letters are there. So we know that A is 1, B is 1, and C is 1 in that specific spot because it's a very specific one that we're looking for. So we can just put A, B, C because there's no other value that we circled with it to compare the A, B, and C values to. So we just found the specific spot. So this is 1 when A is 1, when B is 1, and when C is 1. So this is our f function. So this is what we have as our f function. This is basically A bar, C bar produces 1, B bar, C produces 1, and A, B, C also produces 1. Okay? Now, let's do the same thing, but we have to do it for the g function. So let's recopy the g over here and other ways to better understand. Right? So we're going to do the same thing. Now, if we have prior knowledge from Karnaugh maps, we know that the D is just an extra, but it also represents a 1, right? So the D can also be symbolized as a 1. So let's just put down a 1 here for now, or actually keep it at D so nothing gets confused. But a D also can be represented as a 1 if it is needed to help fill out the chart to make it an easier way for it to be filled out. Right, and that can be further explained in the Karnaugh map video if you guys want it. So when C, we're gonna put C is equal to 1 here, and I'm sorry, 0 here and 1 here, because it's the same concept as this. The C bar line here, it doesn't cross this part, so we know this is 0, and this is 1 where the lines are. So this part is 1, and this part is 1 over the lines here. So A is 1 in these 4 boxes, B is 1 in these 4 boxes, and C is 1 in the bottom row. So that all stays the same from the f function because they are similar. Now, so we have this, and now let's circle them again. So let's erase this actually. So if we are going to circle this g function, how do you guys think we should circle it? Maybe take 30 seconds, pause the video, maybe try to do it for yourself. How do you guys think we'll circle it? So we can only circle multiples of 2 exponents, right? So how about we circle these 2 first, right? So that'll be the first one, the 2 on the top. Now, another thing about Karnaugh maps that you guys don't already know, we always want to try and circle the most amount of ones as possible when we're doing something. So if, for example, in this top left corner, it would be easy to circle this 1 by itself. Oh, and by the way, I don't know if I mentioned it, but we cannot circle one diagonal. Like, this is a no-no. We cannot circle diagonals unless it's on corners, right? So when we always try to circle on Karnaugh maps, we always try to circle as much as possible. So even though this D is already lapped with this 1, we can also circle it again by doing this 1 along with this D. So we circle the top 2 corners. So this is also another circle that we can do. And then we can end up circling this one by itself. Now, if you guys haven't seen the pattern already, what we're trying to do is create similar we're trying to create similar ones between these two Karnaugh maps. We're trying to find the same equation, as we have a limit from the question, right? We can only have 4 AND gates and 2 OR gates. So basically, we're only trying to find 4 functions that are unique from one another. So we have the top 2, which is the same as this one, right? The top 2 in the left are the same as this one. We have this bottom one, the circled one, the same as this circled one in the f function. And then the only different functions are the bottom ones and then the top corner ones. So the bottom corners and the top corners. Those are only one difference. So in turn, we can mentally imagine, we can label this as 1, right? This is 1. Then we can label this as 2. This could be 3. And then this could be 4. And then that would be our 4 AND gates. 4 unique circles that we have found in our Karnaugh map, right? So after we've done that, let's get into trying to find an equation. So if we circle the top 2 over here, let's start. So we have the top 2 over here. So we have the top 2 over here. Now, how do we do this? So when A is 0, it is equal to 1. So the D can also signify 1. So when A is 0, it's equal to 1 in both of them. B is 0 is equal to 1 and B is 1 is equal to 1. So B changes throughout that, so it doesn't stay the same. So A is 0, so it stays the same, so we can write A bar. And it's the same as the previous Karnaugh map. C is 0 throughout both ones, as it never touches when C is equal to 1. So we can also put C bar here for the top 2. Right? So we got that. Now we have the next circle. Let's do the easy one first. So we already circled this bottom one, right? And if you can remember, this bottom one, if it's only one side circled, it's a very specific combination. So you do it whatever each letter represents. So when A is 1, B is 1, and C is 1, then the specific box is equal to 1. So we can just put A, B, C, right? And then we have one more circle, which is the top. So we have this one and this one. So from that, we can see that when A is 0 is equal to 1 and when A is 1 is equal to 1. So it won't work as A differs. So we don't need A in this specific equation. When B is equal to 0, it equals to 1. And when B is equal to 0 again, it equals to 1. So we can put B bar, right? Because B doesn't change. Because when B is 0, it's B bar. Then when C is equal to 0, it's 1. And when C is equal to 0 again, it's also 1 in the top row. So C doesn't change. So then we can end up putting C bar, right? So now we have our 2 equations, right, for both functions. So we have the g function here. All right, so we have the g function over there. So we have an f function equation and we have a g function equation. So now that we both have our equations for both Karnaugh maps, now we can get into actually drawing the real PLA map, right? So let's start off first by writing down all the ones that are the same. So let's see what are the same between the two. So in the first one, we have a bar, c bar, and a bar, c bar that are the same, right? So we have a bar, c bar, which is f and g, right? Then we have a, b, c, right? We have a, b, c, which is f and g, right? Because it's found in both the f function and the g function. And the only ones that are different are b bar c and b bar c bar. So b bar c is f, and b bar c bar, actually, my bad. So b bar c is f, and b bar c bar is g. So now that we have all our equations, let's get into drawing the actual PLA graph, right? Now, this is what a PLA graph usually does. So we have three letters. We have A, B, C being used, right? So we're going to write A over here. We're going to write B over here. And we're going to put a C over here. Now, how do we draw this? We're going to draw 2 lines for each one. So we're going to put one over here, one over here. So these 2 lines are for A. For B, we're going to put a line under B and a line here. We're going to put a line under C and a line over here. Now, you know the line in between the letters? It's connected to one of them. So we're going to put A over here. And we're going to do this. And we're going to draw an inverter. What we're going to do is we're going to draw an inverter for each one. Now, what does inverter mean? Inverter basically means is the same thing as A bar, B bar, or C bar. Because we always assume that the values are 1, right? So an inverter puts the opposite one. So this inverter represents A bar. This inverter represents B bar, and this inverter represents C bar. So let's just connect all the lines now. So now we have A bar, B bar, C bar. Now to better represent, let me just write it in for you guys. So this represents A bar, B bar, C bar. All right, does that make sense to everybody right now? So that's what we have. All right, so now that we have this basic format kind of jotted out, what we're going to do first is we're going to write down our first equation. So let's start with this one. Let's start with A bar, C bar, right? So in A bar, C bar, we have F and G. So A bar, C bar. So if we start with the first equation right here, let's put a 1. So the first one we're going to do is A bar, C bar. So whatever there's an A bar, you put an X. So A bar, let's put an X over here. And when C bar, all the way over here, let's put an X. Right? So you have A bar and C bar over there. And now what we're going to do is we're going to draw a line through it, the whole thing. Horizontal line. And it's going to go all the way through. Now, after this line is created, what we're going to do is we're going to draw an AND gate. Because that's what it is, right? It's A bar ANDed with C bar. So this is an AND gate for A bar ANDed with C bar. And we're going to go further and we'll do the rest after, right? And we'll do the rest at the end. But this is the first step. So we have our first equation, which is A bar, C bar. And we're going to draw a line through A bar and C bar. We're going to cross those out. We have to put an X in them. And then draw a straight line horizontally through everything. And at the end, we put an AND gate to represent the A bar ANDed with the C bar. Okay? Now let's do the second equation. And that second equation is ABC. So then the same thing happens again. So at A, we put an X. At B, we put an X. And at C, we put an X. And after we have X's in all those spots that we need, so A, B, and C, then we put a horizontal line throughout the whole thing. Then we put an AND gate once again. And then this AND gate, I'm going to write in the middle. So it represents A, B, C, and the line continues. All right. So now we kind of get the gist of it. Maybe pause it for 30 seconds and see if you can do the third equation and the fourth equation. Okay. And then we'll fill out the rest of this chart. So we're going to keep going down. Let's extend this chart to make it longer. Okay, so now we have our third equation. And what's our third equation going to be? Let's say our third equation is B bar C. So when our third equation is B bar C, we're going to go across the third. We're going to find B bar, right? This represents B bar. So we're going to put an X over here. And then we're going to go to C. And we're going to put an X over here. And we're going to draw a horizontal line through. Oops. Made a little mistake over there. Overdrew it. So let's put a horizontal line through. Right, so we're going to put a horizontal line through and draw an AND gate, right? It represents B bar C. Then I have our fourth equation. And then we're going to put an X for B bar and C bar. So let's draw this out real quick. So then we have B bar. So when it's B bar, we're going to put an X. And when it's C bar, we're going to put an X. And then we're going to draw a horizontal line through. Put an AND gate. B bar, C bar. Okay. So now we're doing pretty good. We have our PLA graph right here. Now, one thing we have to remember is that this is an F function and a G function. So these ones equal to F and these ones equal to G. So we have to indicate that on our PLA. So at the top, we're going to put F and G. I'm going to draw lines down. Right? So this is basically what the end of your PLA should look like. And one thing too important, the reason why the question says it wants 2 OR gates is because at F and G at the bottom, what you're just going to do is put an OR gate at the bottom. And this kind of solidifies it that it equals 1 if it's compared to something else, because all these AND gates equal to 1. So it will always result in 1. So F will always be 1 and G will always be 1. That's kind of what it's insinuating when we do this PLA graph, right? So this is our final PLA graph, what it looks like. And now we have one final step. Right? So basically, we said that equation 1, A bar C bar is equal to 1 at F and G. So if you go to equation 1, A bar and C bar, because it's a 1 at both F and G, you put an X at F and you put an X at G. Okay? So now you do the same thing for the second one. At A, B, C, it is 1 at F and G. So at A, B, C, equation 2, you put an X at both F and at G. And now we do the same thing for the next two. So at B bar C, it's only 1 at F. So at B bar C, you put an X at F. Now at B bar C bar, for equation 4, it's only 1 at G. So you put an X at G over here. Right? So now we have all our outputs and inputs filled out with these X's to indicate it. We have our AND gates to represent the equation for the PLA. We have everything labeled properly from A bar, B bar, C bar. And these inverters are also very important, so don't forget those when drawing it. And then we put our 2 OR gates at the very end, which is very important to represent that F and G will always be 1 with these equations. So entirety, this is what our PLA graph should look like. Okay? And this is how you'd finish the PLA question for these 2 functions, F and G, while circling the Karnaugh maps. Then we have to find the equations, find what equations of them are the same. So we have this as the same, and then we have A, B, C as the same, and then these 2 are different, right? So then that equals 4. So 1, 2, 3, and 4. Then we have these, and we have to indicate which ones are 1 at F or G or both of them. And then we fill out our graph like this, okay? So I hope you guys understood this PLA video. If you guys want me to make another PLA video or cover any other topics, please comment down below and I'll make sure to make a new video on it or any other topic that you guys want me to cover. If you guys enjoyed, please make sure to like, comment, and subscribe as we're trying to hit 1,000 subscribers. Thanks.